Okay, there's still a few people kind of coming in, but let's kick off. So hopefully you're kind of still with me. I know it's getting towards the end of day 3. Conference fatigue might be starting to settle in, but we'll try and keep this lively as we go through. So just before we get going, I'm kind of interested just to understand kind of who we've got here. So if you're a developer, can you just stick your hands up so I can see? Architect? Ops person? Who did I miss? Managers. Any managers? You're outnumbered by the techie folks. That's cool. Okay, and last couple of questions, because I know everyone loves sticking their hands up in these sessions. Who here is deploying apps on Kubernetes in production? Nice. Who's kind of looking at it and hoping to get there soon? Okay, cool. So I'm Stuart Leeks. I'm a software engineer in the commercial software engineering team here at Microsoft, so I work alongside customers and partners. And I'm going to be joined shortly by Rodrigo Nunes from MercedesBenz. Now, I know what it's like when you're in the audience and there's kind of a whole bunch of stuff that goes through on slides. So I'm going to get this out of the way up front so you don't feel that you need to frantically kind of take notes of stuff. So this is just a link that will take you through to a page of kind of notes and links about stuff that I'm going to cover in the talk. If you don't get it before I click the clicker in a second, I'll put this link up right at the end of the session as well, so fear not, don't panic, it's all going to come good. But for this session, what we want to do is take you through the journey of a container, so kind of the life cycle of a container from development through to production. So we're going to take a look at building and deploying through Azure Container Registry, so ACR, into the Azure Kubernetes service. We'll take a look at how you monitor and get some observability of those applications through Azure Monitor Service with Container Insights. So in the beginning, there's code, right? I sit on my machine, I write some code. I've been told, or I've decided I want to do containerized applications, so I create a Docker file, and then I do Docker build, and I've got a containerized application, one could argue. But that's not really kind of the end point. That's not where we want to stop. So from there, we're going to take our source code, and we're going to put it into a shared repository. And once we've got that shared repository, we're going to use continuous integration. So we'll set up triggers. There's a bunch of tools you can use to do this. For this slide, I've picked ACR tasks. So when the code changes, we're going to trigger a build with Azure Container Registry tasks. And then that will give us an image that's deployed into or sat within our Azure Container Registry. And then from there, we need to get the image from the registry into production. So Container Registry has webhooks. We can subscribe to those webhooks and use something like Azure pipelines. And we can use that to push our images into AKS. Now, I lied. I've got one more quick show of hands. Who here uses Helm? Who here's heard of Helm? OK, still a few hands that didn't go up. So Helm is a package manager for Kubernetes. So it lets us, as developers, describe how our applications should be deployed. And then once we've got the chart, which is the artifact that kind of captures that, we can use that chart to do installations and upgrades of our applications in our cluster. Now, it seems to be a little bit of a kind of secret that actually, as well as container images, Azure Container Registry can actually store your Helm charts as well. And that might just be a naming thing. Azure Container Registry kind of suggests containers. But it's kind of broadening to support multiple types of artifacts. And there's a preview for Helm chart support. So that means we can flow the container images that build up the components for our application, along with the Helm chart that describes how to package it, all through the same pipeline as artifacts in Container Registry. So that's pretty nice. So we've moved on from kind of like just doing Docker build and having an image on a local machine to the ability to share images through a registry. And then we can deploy that into a cluster. Now, in reality, what we see is customers don't just have a single cluster. So you end up with a situation where you've got multiple clusters, and you use them for different reasons. So you might have a dev and a prod cluster. So here I'm showing kind of the image names with the container registry prefix, but then I've got a /dev and a /prod. So within container registry, you can have multiple repositories, and those can actually be multi-level kind of nested in ACR. So we can use this to say, we're going to tag our images in the dev repository or in the prod repository, and we can use that to kind of control where our images get deployed. Now, in this scenario with the webhook, we'll need to filter based on the repository that's in that image name to know where we're targeting. But coming soon, we're going to have a nice feature where actually we can tie down the security at the repository level. So different clusters will only have permissions to pull from certain repositories. Currently, it's at the registry level. If you don't want to do it kind of through the repository piece, then we can do a very similar thing with multiple registry instances. So in this case, we'll have a dev registry and a prod registry. And we'll fire webhooks independently in each of those registries to trigger the pipelines to deploy. Now, we'll run a bunch of stuff in our dev environment. We'll deploy kind of much more freely. And we'll have some testing and things that go through there. So we might run integration tests in our dev environment before we decide we want to push that image up to production, before we promote it through to that environment. And the standard kind of dance for moving images between registries is this pull tag push. So you pull using the tag that has the source registry, you re-tag that image once you've pulled it down, and then you push it, and that will target it to the destination registry. And with ACR, what we have is a really nice service-side feature to do that in a single step. So we can say to the production registry, go import this image from another registry. And that takes out that kind of pull tag push dance from the process, and it just happens service-side. And now at this point, one of the things I want to call out, because we've got kind of a diagram showing multiple different things accessing container registry. When you start setting this stuff up, it's kind of tempting to enable this thing in the portal. I'm going to plead with you not to do that. Every time you do that, Steve down here, who's the PM for ACR, starts crying. He bursts into tears randomly each day, and he has no idea why, and it's all because someone has flipped that switch. So please keep him happy. Please don't do this. Instead, what you can do is create service principals, and then you can go in on the registry, and you can assign a service principal through, and you can give it very granular permissions. So you can set it up so your clusters can only pull, and your build agents are the only things that can push. So you can kind of get much more fine-grained security. There's a new feature that will be coming soon for token support. So if you prefer kind of the token-based approach rather than service principals, that will be lighting up for you very soon. So coming back to our kind of multiple clusters, as we go through, I was talking around kind of the testing that you'll do in your integration environment before you promote an image through to production. And there are other things we can do as we go through this as well. So another thing you might want to start looking at is using the webhooks in ACR to tie into things like security vulnerability scanners from Aqua or Twistlock. So these can inspect your images, look inside and see what you've got in there, and see if there are any known vulnerabilities for those packages that you've imported, either in the base layers or the libraries that you've directly added in your own layers as you've built up your images. And if you think about kind of, well, what happens if I do find something that's a known vulnerability? Well, if we were back in the VM kind of deployment world, then we'd be thinking about going and applying OS patches and application patches on the VMs. But in a world of containers, the notion of going in and patching containers just doesn't really quite stack up. So what we want to do is build new images. So we're going to have kind of dependencies that we'll take through the base images that we build on. And what we want is to be able to pull in the updated versions of those when they've been patched. So within ACR, when you use that to build your images, it can also scan to see your base images that you're using, whether they come from Docker Hub, the Microsoft Container Registry, Azure Container Registries that you have set up. And then it will register, if you opt in, it will register for notifications when those images change. And it will use that as another trigger to do a build. So you can have builds triggered when your code changes and builds triggered when the base images that you're dependent on change. So you keep that flow through, and then all of those artifacts flow through the same pipeline of registries and then through to deployments. So what I want to do now is just kind of show this in action, because it's kind of nice to get the picture, but I kind of like to see this stuff actually happening. So let me flick over to the demo machine here. So for this, the key piece of this demo is not the application itself. So I've gone for brain-dead simple application. The key bit of this is the pipeline that happens around it. So I've got an application here. It's pretty simple. It's just a little web server. It's not using anything fancy at all. It's pulling in a few environment variables so that you can configure what it's going to render, and then it outputs that. So that's kind of not a lot to see there. Then I've got a Docker file, and the Docker file is using multi-stage build. So we pull in the Golang base image, and that's got all the tools for building and working with Go. So we start from there, we run the build, and then the next stage of this is to start from a different base image that's got potentially some dependencies that we want for multiple applications, and then we copy the output from the previous stage into that. So when we deploy, we don't have all of the Go tooling that's going to bloat the image size. We don't have all the tools that are there and as a potential security threat that we need to think about. We have just the pieces we need. So we've got this base image. Now, in actual fact, this base image comes from another Docker file here, and it's doing not a lot at all. So the green and white coloring there matches the green and white that's there. So we're on the base image that's currently checked into to source control. So we've got all of this, and this is going to be built and pushed to a registry. Now, I talked around Helm, so what we've got in the code here as well is a Helm chart, and this just has some pieces in here. So under templates, we've got the templated Kubernetes manifest for the deployment. There's another one for the service. And then with Helm, you get this values file, which is kind of default values to inject for the templating that happens. And these can all be overridden at deployment time. So in here, I've just got my qualified image name that's coming from ACR. And what I'm going to do is come in and let's pick the right window. So I'm going to go through right from scratch, setting up a build task that will be triggered by source code changes and also by base image changes. So we'll set that up, we'll kick that into action, and then we'll trigger a change to the base image shortly. So we can come in here and we can say ACR task, and we want to create a new task. Now, the first thing I do whenever I run a command line is try and figure out what it's really going to want me to say. So I run it without any parameters, and then it can have a good grumble at me and tell me what the bits are that I need to put in. So we need the name and context. That's good to know. So we'll give it a name. Oops. That's rendering weirdly. Let's quickly do that. There we go, that's better. Name, build, demo, because I'm not very imaginative. Context is where to go grab the source for this, so let's put that in. Now, there's a couple of other things that it needs. Firstly, it needs the ability to go read that source. Let's give it my GitHub personal access token I created for the demo. It also needs to know, well, once I've got that source, what should I do with it? So I'm going to tell it to use the Docker file that's in there. So it will then go, OK, well, I'm going to go build that Docker file and process that, and I'll take the image that comes out of the end of that. And then the last thing is I need to tell it what to name the image. So I'm going to call the image demo because that's what all the rest of the pipeline is expecting. And then we have this ability to use kind of like macros or variables. So in here, I'm just going to say, use the identifier for the current run of that task. So that would give us a unique ID to use for the image tag. So we'll have that kind of piece pumping through. Cool. So when I do this, the ACR task will be created. It'll be linked to that GitHub repo. It'll set up a webhook on that GitHub repo so that whenever that changes, it gets notified. And then it can use that to trigger the builds from source control. There we go, cool. Now I'm going to show you a huge load of, what did I call that build demo? So we're going to take a look at a large load of JSON coming back in a sec, because what I want to very quickly show is kind of the dependencies that are wired up in here. So in here, this is going to give us a full kind of definition of the task that's just been created. And you can have multi-step tasks, so this is going to be there's going to be kind of a set of steps, but there'll be a set of steps of one. Now in here we can see we've got the source triggers, so this is the GitHub URL that I just put in, so all of that's in there. And then as we, excuse me, as we look a little bit higher up, we've got base image dependencies, and it's null. And the reason for this is it hasn't built this Docker file yet, so at this point it doesn't know anything about the base images we're going to use. So the first thing I want to do in here is come in and just tell it to run that task. So I'm going to do task run, build demo. So that's going to go and start this task. So when it does that, it'll find an agent. It'll tell that agent to go pull that source code from GitHub, It'll find the Docker file, because that's what we told it to look for, and then it'll run through the set of steps in that multi-stage build. And the output that you'll see here will look very similar to if you were just doing Docker build on your own machine, not by accident. Like, we want this stuff to feel nice and familiar. So the output that you're going to get through here feels like you're doing Docker build locally, but this is happening in ACR. This is happening in the workers for the tasks for your repo. So it's pulling down the Golang image, it's running the build inside that image, then it's moving on to the next step, which is pulling the base image. Then it's going to take the output from the build image, put that in, and then push that resulting image back to your repo at the end. What I should have done actually in here is it's kind of nice just to have something that we can watch those tasks. So I'll set that going so I can flick back to that in a minute. So that's now pushed through a new build of the image to our container registry. So the other piece that we're going to want in here is, well, how do we go and deploy those pieces out? So in Azure DevOps, I've got a release pipeline defined in here. So this release pipeline is going to be the thing that will be triggered when we get the new image pushed. And it will use the Helm chart to then go deploy that new version of the image. So we've got a fairly simple piece in here. Go install the Helm tool on the agent machine, so we get the right version of that pushed through. Then we've got an Azure CLI script, and in here the key pieces are we're going to use the Helm repo add command under ACR to go and add the Helm repository for that Azure container registry to the set of Helm repositories that the Helm tooling knows about. Then we do a Helm repo update, so the metadata gets pulled down, and then when we come back and we start using the Helm upgrade command, that's going to use the Helm repo that we just added from ACR. So we're going to issue an upgrade. We're giving it the chart name, so this is qualified to the registry so it knows where to pull it through. And then the image name, when we get triggered by the webhook from ACR, we can get the tag in this build ID property that comes through here. So we can tell Helm chart to override the values file that I showed you a few minutes ago with the value of the tag that's come through from that instance of the task run. So at that point, we can trigger that piece going through. Now, one piece that I just need to do in here is to come in and enable this trigger. So let me just save that. So that's now registered the webhook with the registry to say, let me know when there's a new image, and I'll kick this off and start the pieces moving through. So back in here, we have the Docker file for the base image. So let's move away from green and white and come to a more black and white. And actually, kind of, if you're going to do any demos like this, I kind of feel you shouldn't use white as a background. You should use Azure because it feels more appropriate. So we'll replace Hello World with Hello Build as well. So we've got those changes, and we can come in here and we can say, I want to build that new base image. Now, if I was just doing this on my local machine, I'd do a Docker build, I'd tag it with the base image name, and I'd give it the context to use. So that would be the flow through that I'd have for this. Now, what I'm going to do is just change the Docker at the start of that to ACR, just to really kind of drill in this point of we want this stuff to feel familiar, so the patterns that you're used to really do play out and work through with this. So instead of this doing a Docker build locally, this is going to take that build context that would normally send to the Docker endpoint on my machine and push that up to ACR, and then that will run through and trigger a build. So that is taking that step through there. Let's flick over to watch command's gone funny. Let's see if we can flick back. Cool, that's sending the context. So in here in a second, we should see the list of task runs, and we'll see that there's a new task that's been kicked off as soon as we get an agent. So this build ID is the piece that we pull through from the image tag that then is the piece that we pass into Helm. Oh, we've got the manual run there. Wow, 13 seconds, that didn't take long. I'm going to be too slow. What I want to do is show the logs. Can I catch that before it finishes? Let's see. So when it's a build that's been triggered by a commit or a base image change, you're not interactively running that, so you don't necessarily have anywhere to see the logs. But if you want to go and inspect the logs for that, you can run the task logs command, and if you don't pass any parameters, it will show you the last build that's gone through. And the base image went through a little bit quicker than I was expecting, so we might not see any output there. Cool, yeah, we missed it. It's gone through, it's too fast. But if we come back in here, we'll see we've got this new build that's going through. So the pipeline for release has been kicked off. Cool, so that's running the AZ CLI login piece, then that'll do the Helm repo add, go do the Helm repo update piece to pull down the metadata about the new repo, and then in just a second, here we go, we're moving on to doing the Helm upgrade command, so that's passing through the image tag through here to go and tell it to deploy a version that's got that newly built image, and then when that's gone through, that will kick off the change to the deployment in Kubernetes. And as we come back to here, we have the newly deployed version that's gone through. So that's been triggered purely on the basis of us updating the base image. So the base image got built. That triggered the build of the application image. When that completed, that triggered the release pipeline. That pulled the Helm chart down and used that Helm chart to go update with the image tag right through to the cluster. Cool. So that's given us kind of a bit of an overview of kind of some of the pipelines to put around kind of getting your images from development into production and a bit of a hands-on kind of feel around it. What I'd like to do now is switch gears. And I'd like to invite Rodrigo Nunes from Mercedes-Benz to the stage to talk around how they're using containers in the software for their cars. Welcome, Rodrigo.
All right, hello everybody. Thank you. So at our office, this is a picture of our Sunnyvale office, by the way. We are here by the waterfront, so a couple of yards almost from the convention center. But what we're trying to do in our office and my team is to modernize the way we develop and deploy software inside of the car.
So you're looking to modernize it. Just to help us understand, can you give us a bit of context for what that process looks like now?
Sure. So at the moment, in order to build and deploy software inside of the car, the software that runs inside of this computers that power the screen and the dashboard in your car is very static. It's very hard to send updates. The updates are very infrequent. Many times, the software is flashed inside of the vehicle, and it comes out of the factory like that, and any updates will be done maybe once or twice a year. You have to take your car in. So what we're trying to do is make a piece of that software updated more frequently and have some continuous deployment of applications inside of the head unit.
Okay, cool. So you're trying to kind of change the flow that those pieces are going through, really?
Exactly. So we take some ideas of software development for other types of services, for example, and when we don't have to wait to deploy the software inside of the car, so we try to build an ecosystem of tools for developers to get off the ground, remove barriers for them to innovate and create applications. So by doing that, we're trying to foster innovation in the company and let people transform an idea into a prototype that they can show and get started.
Okay, so I don't have a Mercedes-Benz, but when I get inside the car, the first thing I do is kind of take the phone out of my pocket, and that's kind of my in-car experience. I guess you want to move people away from that.
Yeah, no, we don't want you to do that. We want to own that interaction. We want to own that screen. And in order to do that, we need to offer something more appealing. We need to offer applications that are up to date, that can have features added. I need you to be able to purchase new applications and get them to be updated like you have in your phone, for example. So take a card from iOS or Android development when you have emulators and an ecosystem of tools that let you build these applications in some quicker fashion.
Cool. Click to the next.
So in summary, what we're trying to, if I put in like one phrase, what we're doing is trying to have container-powered cars. This is a very broad statement because it's not a full car. There's a lot of software that runs in the car. But what we're trying to provide is this dev tooling and emulation and a way for you to build things locally, test locally, and iterate before you go deploy things into the car. So imagine that now, by having to make a change to an application, you have to go to a garage and check if your software is working or not. There's no way for you to do this full development and contained locally. So I want you to pick up your laptop, be able to open it, have an idea, write the software, and have it ready.
So if I had a dashboard that looked like that inside my car, I think, and the apps kept up to date, I think I would just keep my phone in my pocket.
Right, and more important is to keep it up to date because what's cool today might not be cool tomorrow, so we want to keep evolving the software.
So can you tell us a little bit about how you're enabling that kind of app update through the use of containers?
Sure, I can. Well, I have a simplified version of in here for in lieu of time, so I don't want to be going through many details. But imagine that you, as a driver, purchase applications. You have an inventory of applications that you own. In order to keep those applications current, I need to constantly be pulling information from my backend that will tell me what are the latest versions available for those applications. So by using containers, I can just have the dev teams completely decoupled from the release management, for example, and they can create new versions as fast as they want. They won't be published in production because they have to go to the QA process. But right now, when they are in production, they will be having a configuration file that is controlled by our operation. So the flow works like, in a simplified way, you turn on your car, the car goes through APIM to one of our clusters, depending on where you're driving. In North America, for example, in Europe, we have China coming up soon. And based on the car and the driver, I'm going to get an inventory of applications with the latest versions. When it comes back inside of the car, there's orchestration that will verify which applications are already owned on those versions and which ones need to be pulled from ACR. We have a geo-distributed ACR. That was actually a great feature. That was almost like a request they would make, but an excellent job from Steve Lasker and the ACR guys. They helped us a lot in this journey. But what I can do in here now is if I'm driving in Europe, for example, and I need to pull an application in a newer version from my registry, I'm going to go to pull that from our replicated Europe location. If you're driving in America, I'm going to pull that from the same registry name, but now under the hood, traffic manager is operating that traffic and driving it to the North America register. So minimizing the latency to have them inside of the car. So once I have them all inside of the car, I'm going to start and stop the applications, and I have a newer version updated. So I no longer have to wait for longer cycles. I can update this as frequent as possible and make this process more swift.
So you've got containers powering the back-end experience as well as containers for delivering the applications down into the car. So container-powered cars is really becoming kind of a reality.
Exactly. It's baby steps. You know, it's a small portion sandbox inside of the head unit, but the idea is that we can grow this ecosystem.
So when you describe kind of the journey that you're trying to take on the modernizing, kind of getting the apps down to the cars was one piece of that, but you're also talking around the developer experience. Can you tell us a little bit about how that's changing?
Exactly. So you might be thinking, okay, there's a geo-distributed ACR, but how do the images end up in there? So another simplified version of it, but what we built for that improve this and remove these barriers for somebody to create an application is we created a portal that, aside from giving you a head start on a Hello World application, it also creates resources in Azure. So I'm going to create a repo for you. I'm going to create a private registry for you, a pipeline that build your software in multiple architectures. It's important for us to have the software built in both ARM64 and AMD64 because I want to run this locally in my laptop or in a PC or a Mac. So I need the AMD version. I can do the full development locally, but I also need this application to eventually run in a car. So I'm building an ARM64 version. So in that way, I can enable a developer to continuously deploy new versions of this application and add new features, fix bugs in a much faster way, in the way we are used to software development for microservices, for example.
Cool. So you said this is an ACR that's like private to the dev team.
Yes.
There's still a disconnect then between that and the geo-replicated registry.
Right, right. Good question. Yeah, you might be thinking, or maybe more than one person here might be thinking that, well, you're allowing the developers to just go to town and push software as fast as they want to production. Again, this is the private registry that we created for them. So there's a process where these applications will end up in production. There's a production registry that will be owned only by release management, QA, and completely off hands to the developers. So for that, we have pipelines that build the applications, moving from their dev stages whenever the teams commit to a development branch during their sprint. We're going to be building, running all sorts of static testing, both integration tests, and this image is being pushed to their private registry. But moving forward, this image will then be tested in a real vehicle, and from the QA process in integration environment, it will eventually end up in production where they can be now fetched from the vehicles. So in a summary, I built a new application, I tag my new image, I create a new configuration, push to my Cosmos database. The whole process when the car gets turned on, fetch and deploy is going to happen. So there are some gates through this process that will be verifying many conditions and preventing applications to make it to production without proper testing and stability. So
well, I noticed you've got a gate showing there with Azure Monitor alerts.
Yes, yes. Azure, in fact, we do very, very extensive use of metrics. We built, we have a dashboard here. I'm going to have to talk to the team because there are some pieces missing there, but believe me, they're there. And this Azure Monitor gives us this full X-ray of all of our operation from the Kubernetes side all the way through each individual service running in production, and giving us an idea also about the latest logs and counts. And we built alerts over failures and possible things that might be interesting for us to investigate. So an on-call is going to be completely covered in terms of having a full snapshot of what's happening now to also be able to investigate and quickly troubleshoot any problems. So this was a little hard for me as a former a person that worked at Elk my whole life. I'm a big fan of Elk, some of you might know. But this, to be honest, exceeded our expectations, and it was a great job also. So it's doing great for us.
So you've got the dashboard to kind of give the high-level visibility. If you get issues or things you want to investigate, you drill down into those, and then you said you feed that back. So we saw kind of the alerts both on the deployment side, but you're saying you also feed that into your ops tooling as well.
Yeah, yeah. We have SMS, and we have email, and we have integration with our paging system. So this is like a full visibility for us and also a good way for us to understand how things are at any point in time. We have big screens in the office, and everybody can walk around and see what's going on in all of our services. So.
Cool. I'll flick to the next slide for me. Cool. So as a taste of the journey, if you'll pardon the pun, that Mercedes-Benz have been on to modernize their app. So thank you again, Rodrigo, for joining us and giving some insight.
Thank you very much.
I'll take this.
Oh, thanks.
So we just saw a little bit there from Rodrigo about how they're using Azure Monitor. So we've got Azure Monitor that kind of gives us telemetry across all the Azure services. And part of that, we've got Container Insights, which gives us insights into the Kubernetes cluster and also lets us capture information and metrics from the containers that we have running inside the cluster. And that'll soon include scraping of Prometheus metrics, so you can bring all of that into the one location. So since it's kind of getting towards the end of the conference, I'm going to avoid going too slide heavy. So I'm going to flick back to demos and just kind of take a bit more of a hands-on tour through some of the things you can do with Azure Monitor. So let's get rid of that window. We don't need that anymore. So here we see the top-level kind of view of Azure Monitor Container Insights in the portal. So if you go into Azure Monitor and click on containers over on the left-hand side here, you'll get this view across all of the clusters, across all of the subscriptions that you have access to, across all of the regions that they're deployed to. So it gives you this kind of high-level view down over the estate you have of AKS inside of your deployments. So I'm going to take a quick look down here and pick one of these clusters to take a look at. And let's get every last pixel out of this projector that we can. So at the top level within a cluster view, you get a kind of a view over your nodes and pods and the things that are deployed. You can kind of click through to change which lines kind of show up on the graphs for each of the views, so you can quickly kind of filter and slice and dice those pieces. And then you can drill down and take a look at your nodes. And one of the cool little things is kind of a little bit of an extra kind of bonus, but if you look there, you can see a tiny little penguin kind of in there. So this is one of our Linux nodes. And then down in here, we've got a little cloud icon, because this is a virtual node. So if you're using virtual nodes, you'll be able to distinguish those nodes very visually. It takes kind of no cognitive processing to be able to kind of pick the right nodes as you start going down there. And if you're using the private preview for Windows, there'll be a Windows icon on those nodes as well. So it's very easy to kind of disambiguate as you start looking through those pieces. And at the top level here, we can filter by kind of memory usage, CPU usage, and quickly see that across the nodes that we have there. And then, as we start to drill down, we can start to look in and see what's running on each of the nodes. We can link then back to the controller, so whether that's a deployment, replica set, et cetera, and start to get that kind of view as we look through these pieces. So I'm just going to flip back. So the other piece that's on this tab that we saw initially is clusters that you aren't monitoring. So this is a great way to kind of say, okay, which bits haven't I got visibility into through Azure Monitor? And then you can very quickly kind of just drill in and enable those. And as you drill down in here, you can come in and you can choose which Azure Monitor workspace the data should flow to, so you can group things like that if you have different workspaces you want to use across different environments, et cetera. So I've got another cluster here then, and we can see on here we've got some slightly more interesting data coming up for the node utilization. So if we start to click through to the nodes here, we can see we can easily pick out the different nodes here. All of the nodes are currently reporting healthy, so if you did a kube control describe on the node, it wouldn't have any out of memory, out of disk space notifications coming through. But down in this bottom corner, we do have a little warning icon showing up against local disk capacity. So as we look in here, what we have is, so when you enable monitoring in a cluster, it actually adds the add-on to AKS for monitoring, which will go and deploy the daemon set for the OMS agents, so that all those pieces get deployed and can start feeding this information back. And this warning is coming through here because one of the disk devices that we have here has hit 93% utilization. Now that happens to be a device that Kubernetes isn't monitoring, but the OMS agent's picking this up and flagging it up and making it nice and easy for us to see this as we come in here. So we're getting a really nice kind of view inside of the system here. Now this one's kind of a, you know, an eye grabber, right? You know, there's a lot of red there, which instantly kind of grabs our attention. And as we kind of start drilling down into here, we can see that same set of information showing, so we can easily see that, sure enough, we do have some rogue pod, which is kind of, you know, demoware to go chew through CPU. But it's there, and it's easy to drill into these pieces and start to find those bits of information that you want. So we've got kind of a nice graphical high-level view we can drill down, but if you want to start getting into the data and slicing and dicing it a little bit more, we can do that as well. So we can come in, let's go into analytics. So the docs actually for this, there's a whole page of docs which are in the links that I give you around how to grab all of that data and assemble it into useful pieces for different things. So this one happens to be for querying CPU utilization. But there's another nice little feature in the querying here, which lets you put in functions, so you can save queries and functions. So I've got a couple of little helpers there, so I can make this a little bit easier for me to work with. So I can just bring one of those in. If you like keyboard shortcuts, Shift-Enter just gives you run whichever query you're on. And then down here, I get the data that's coming through. So I can take that data and let me just switch that to just the last 30 minutes so that we're just showing the recent data coming through. I can take that and I can start to run some queries. So we get this ability to kind of project the data out into different forms. So I can take the average of the usage percentage, and now I can see that the average usage across my cluster over the last 30 minutes was 23%. But actually, what we want to do is to show that in different ways. So I can say, summarize that average by computer. So that will show me across the different computers what the utilization was on average over the last 30 minutes. Or I might decide that actually what I want to see is not just by computer, but I want to see over time how did it look. So I want to take that in kind of time-windowed buckets. So we can create bins of that data. So I can do a bin on the usage percentage, and I can just say 1 minute. So if I wanted 1 second, it's that. If I want 1 minute, it's that. So it's nice and easy to kind of create these groupings. And then as we run that, where did I put? Oh, hang on. I want to do windowing on time, not on the usage there. Cool. So now I've got this data coming through in kind of the time buckets, and I could change this to say, actually, I'd like you to just show me a line chart of what that looks like, and I can very easily kind of project that out in different ways and view that. But it might be that actually what I want to see is, by computer over time, how does this look? So we can, summarized by, we can actually give it a list of different fields that come in there, and then we can see that in line graph form. So we can very quickly get to this, how do things look by time, by computer over time, and slice and dice these pieces. So let's take a little look at a couple of other pieces then. So that was looking at some of the metrics and events that are coming through. If I take a look in here at this, I can add a filter, so I can filter this by different things. One of my favorite filters is everything but cube system. So it's typically all the stuff that I care about rather than all the stuff that I don't. And then that'll filter down. Now in this case, I actually know that I'm looking for a particular pod down in here. So we can look down in here and I can see the different pieces that I've got coming through. And if I click on one of these, I can say, show me the live data. Let me zoom out. So we've actually got the logs streaming through directly in the portal from the logs from that container standard out. So I don't have, my need to go to kube control is kind of diminishing rapidly as I go through this. And we can start to highlight some things in here. So I noticed something went past a minute ago. So I've got this set of messages coming through showing request finished in a certain amount of time. So I'm like, ooh. Okay, so I can get some data out of this and start to say, well, okay, if I've got this flowing through, could I query that? And could I do something useful with that? So if I come back into the analytics piece and start running some queries, I'm a big fan of delete and start from scratch. don't know why. But I can come in here and so I can say container logs, and you notice you actually get some quite nice kind of rich IDE-like experience of the queries directly in the browser here. So I've got my container logs, and last time we did some summarized kind of actions. So before we do that, I'm going to filter down the set of pieces that we're looking at. So I want to only find log entries that have finished in them so that we just narrow down to the pieces that we want. I'm going to temporarily add a new piece in here just to simplify the queries, and I'll come back and take that out in a minute as we build up the complexity. So I've now filtered down to just the rows that have finished in, and there's still a whole load of columns. So what I'm going to do is give it a new projection. So this just lets me say, these are the fields that I care about. So it's a bit like a select statement. So let's come in here and have time generated, log entry, computer, image. That's probably a pretty good set. So we can start to see as we drill down in here that we've got all of these pieces. And what we want to do now is pull out that numeric value that's in that string. So I want to go find that data, and then I can start doing some more interesting things with it. As we come through here, what I want to do is extend the set of columns in my output. So I can come in and say I want to extend, and I'm going to create a duration in milliseconds field. And that is going to be equal to, and this is the bit where you have to do the magic to take the value out. So what I want to do is extract the value from there. Now, as you start working with this, there's actually this nice help page in here, so we can come in and say, go show me the help for the query language, and then I can drill into the reference. And then the docs have this nice filtering, so I can very quickly get down to the pieces in here where I can see, okay, so I need to pass in the regular expression first, and that will capture one or more fields. Then I can tell it which of the capture groups and then where to go get that data from. So let's do that. So we're going to put in the regular expression. I'm going to come back to that because I have to think about that. Let's just say we're going to capture the first and only capture group in there, and we want to take that data from log entry. Now, I'm also going to put in an additional field here just to say treat the value that comes back as a floating point number. So my regular expression, I want to capture something, and it's going to have milliseconds at the end. So the bit that I want to capture is going to be any digits, and then we've got a decimal place in there. So let's capture as much of that as we can with milliseconds at the end. And then it'd probably be good to bring our new field into the query. So as we do that, we can see that our output has the duration field that is matching the value that we pulled out of the log entry there. So now we're at the point where we can start doing the summarized stuff that we did before. So let's dig into some of those pieces. So we've got this, so we can summarize. And again, we can take average of duration. So our average duration is 6 milliseconds, so that's pretty cool. But again, we can do that by the time kind of series piece here. So let's do time generated, and let's do that on a 10-second interval. And this time I know that I'm going to want to look at it as a graph. So rather than each time I run the query, flicking the view at the end, I'm actually going to tell it how to render this. So I'm going to say render it as a time chart. So each time I run this query, I'm going to get this time chart coming out at the bottom here that I can look at. So this is kind of nice. We've got kind of a couple of things that are going up near the 10 milliseconds mark, but mostly it's kind of quite quick. So what I can do in here is, I might want to decide that I've got a baseline for requests that I want to have as my comparison. So a baseline is just like a constant value across this row, right? So I just need a new field that just has a constant value. So we know how to add new fields, we extend. So I'm going to extend and say baseline is, all right, let's pick 10. So now I rerun the query, and it's rendering the output, so I can very easily see where I am against the baseline of what I think my response time should be. So that's pretty nice. So we can take that and then start to look at some more pieces. So let's mess around with this a little bit. So I had a funny little filter that I put in at the start, and when I take that off, suddenly my baseline is looking like really close to 0 compared to the actual response times that I'm seeing coming back. So this is one of those points where you sort of scratch your head and think, well, okay, I need to dig into this a little bit more and see what's going on. So I might decide that actually, you know what, let's let's summarize it by time and by computer so I can see, well, is this a node-based kind of thing and some nodes are worse than others? And well, when we do that, we definitely see that there's some nodes that are really not looking great, but there's other nodes that are still like 50 to 100 milliseconds. That's still way off the baseline that we just established. So maybe that's not the piece that I want. So what if we try it by image? Let's give that a whirl. Well, okay, so now this is vanishingly small compared to the responses up here. And as we look in over here, we can easily see that kind of this API 4 tag has the much higher version, and the API 1 has the lower version. So we've kind of looked in here and gone, maybe we screwed something up with the newest version of the image that's gone through. Maybe we need to go look into that a little bit more and see what's going on there. So we can really quickly kind of work with this data, and we kind of get this pipeline of data that comes through. Personally, I love the summarize, because some of this stuff feels kind of like SQL, but with SQL, you'd end up adding something into the group by and into the select, and you kind of lose that. It just becomes much quicker to kind of go and add this stuff and drill in and figure out what it is that you want to do. So another thing we can do actually in here that is also really powerful is as we start to look in on this, let's tweak that a little bit. Sometimes it's not just averages you want to work with. Sometimes you want to get a median out or something like that. So let's take the duration and just say we want the 50th centile. A comma in there would work. So we can come in and we can get the 50th centile versus the average. If you want to be able to put multiple centiles, you can use the percentiles function. Subtle difference, but this one takes multiple arguments, so we can easily throw in like, what are our 95th, 99th centile response times. At that point, maybe you come in and you go, actually, yeah, I want to kind of drill this in so it's not quite such granular time windows because it's really hard to see. And you can start to produce different charts as you want to investigate these different pieces nice and easily. So let's take out a couple of these bits because, often you'll find that you're wanting to do this investigation when there's something that's not quite right. And you might not be the only person looking at this stuff. There might be other people looking at it. So there's this really cool copy link. So copy link copies that to your clipboard. You can stick that in Teams, in email, write it on a piece of paper via your old shortener. It really doesn't matter. Pass it to colleagues who are working on that. They'll click on that. They'll sign in. And then they come up with exactly the same query over the same analytics portal, and they can start diving in, and then you can jump on the phone and chat through, oh, what if you did it this way? What if you did it that way? So it really helps with that kind of collaboration and sharing. Or maybe you're writing up a report, and you want to be able to say, this is the query I ran. You take a screenshot of it and then put that in, but you can also give the link right back to the query as well. So that's a pretty nice kind of little feature that you can take advantage of. I'm just going to take a couple of pieces out of this query here now. Because another thing you can do is add an alert rule. So if I come in and add an alert rule, then as I come through, this condition has picked up the query that I had in here. And I'm just going to tweak this so that instead of number of results, it's going to look at the metric measurement. So the thing that's the metric that's inside the query that I've created. So this is giving me a little error in here saying you need to have a field called aggregated value. So I'm just going to name this field here. Aggregated value equals, and then that's happy, and I can come in and say, well, okay, the threshold for this is 20, so 20 milliseconds. I can specify the period that I want it to exceed that for, and then I come through, click done, and then tell it which actions I want. So I can come through in here, and I can have actions to email me, to send me a notification to the Azure app on my phone, fire off webhooks into ops tooling, whatever you want. So all of those pieces can come through. And then the final piece, if I scroll across a little bit further in here, is pin. So pin lets you pick a dashboard that you want to pin it to. So I've got a dashboard I created there that's a shared dashboard. And then that is kind of how you compose the, let's do the sign in. That's how you compose those dashboards that Rodrigo was showing of the different pieces that you want to build up, to put on nice big screens. Couple of horse dances. So you can build those and you can share those dashboards out as published dashboards across the team. And there, boom, we've got the chart up on a dashboard that we had there previously. So there's quite a lot of richness there around kind of starting at the kind of sky-high view across all of your clusters, being able to drill into a specific cluster, looking at some of the nice dashboard pieces that are there automatically for nodes and pods, drilling down into containers, looking at the logs, looking at the live events, and then moving right down into querying across those different data sources, and then setting up alerts and dashboards and pieces there. So I want to come back to kind of another piece that we were looking at a little bit earlier, which is kind of when you start deploying across clusters. So the fact that we've got monitoring that supports cross-cluster is kind of great, because I can have an application that spans multiple clusters, and I can have one set of monitoring tooling working across that. So the classic kind of pattern that we see for multi-cluster deployments, whether it be for high availability or geoscaling, so that you get services close to the users that are consuming them, is you put something directing your user traffic, so either as your front door or as your traffic manager, those kind of pieces. Those will route to services running inside your cluster. And then at the back end, you'll have a data store that you replicate typically. So Cosmos DB was what Rodrigo was using. And when you start thinking about this, as well as kind of the monitoring and needing to pull that across all the clusters, you also need to think about how you deploy your images into the cluster. So the images are going to come from a registry. And really what we want is to have the registry images available in all the regions that our clusters are, so they pull from a nice local piece. And ACR geo-replication, which Rodrigo was talking around earlier, which they make extensive use of for pulling the images down to the cars, is also great for the deployment of your services. So if we don't have a replicated registry, and we maybe have deployment of clusters in a number of locations, then when we come to do a push, we need to push to a registry in the US and then a separate registry in Europe. When our clusters are pulling down the images, they need to know which registry to go use. So we have to configure the pull to pull from different registries from each of those clusters. And additionally, if we haven't gone to the extent of putting registries in all of the regions, then we're going to see some of these regions that aren't pulling from network local registries. They're going to be introducing egress costs on pulls, and it'll be a slower pull, so that the time taken to push new images down to the running clusters will be higher. On the flip side, if we turn on replication for our registers, we can have a single logical registry that has replicas in each of the regions you select. So then the push is just a single push to the logical registry. The registry will then replicate that across all of the replicas that you've asked it to. And each of those replicas will have its own webhook that you can subscribe to trigger the deployment in that region when the image reaches that point. So at this point, you've got a really nice story for the deployment across multiple regions for getting the containers out there. So we've seen quite a lot, and I did promise I'd show you the links again. So we've taken a look kind of building and using the promotion patterns, security through security scanning with ACR, deploying via Helm into AKS, and then using Azure Monitor to give you the kind of dashboarding, querying, alerting, and reporting over the top of those pieces. So with that, I'd like to thank you all for kind of lasting this long into the conference. We have 2 minutes if you have any questions, but thank you very much.
Excellent.
Cool, go for it.
Yes, thank you for a great session. Question is when Helm charts on Azure Container Registry will be GA, because now it's in a preview.
It is in a preview. So Steve was here.
He ran.
He's done a run it. So there's a dependency on Helm 3. So once that's there, that will simplify a bunch of stuff, and then it'll be looking to come out of preview at that point.
Okay, thank you.
I have a question to Rodrigo. Once your clients, your drivers, set their preferences on the car, and you need to deploy a new image, how do you keep the preferences? How you handle the situation?
Well, that's a very interesting question, because we are working exactly on that right now. But we have a mechanism of priority that we are envisioning, but we don't have yet the backend to set those priorities. But that would be pretty much, the driver would select a priority for his images, and then once I'm starting to have limited resources, I'm going to be prioritizing always from whatever he selected in some other system, probably on the back end, a website or a portal where they can manage the applications. But there will be the solution coming. That solution is not in place yet.
So we're technically out of time, but if you want to just come up and ask questions while we kind of pack up, we can get out of whoever's presenting next as well.